Hi, my name is Robert Pugh. I'm with IBM. We're going to be talking about Guardium Data Encryption today and how to set up policies to protect a Windows server running Microsoft SQL Server. Before we get started, you should already have the GDE agent installed and the host server registered with the DSM. We did this in a previous session, so please check my channel for that video. We also need to choose a method, whether to protect and then copy the database files into our folder or to protect the folder with the database files already existing. There are slight differences between the two methods, and hopefully that will become clear as we proceed. Okay, so the basic process is going to start off by creating a key. The key is going to be used to encrypt the data. Then we'll create a policy in learn mode. Learn mode is going to let us watch what's going on without actually doing any enforcement yet. Then we'll create a guard point. Guard point is going to be specifically saying where to apply the encryption. And then we tie those two together so that whenever somebody accesses data within that folder that was protected by the guard point, the policy is going to be applied. So once we have that done, we can exercise the database, do a few normal activities on it, and then go back and examine the logs. The logs are going to tell us what the services are, the processes that were accessing the data, who the users were that were accessing the data, what they were trying to do, read, write, etc. And then we can go back to the policy and update it, allowing those things which should happen and disallowing the ones that shouldn't. Finally, we'll remove learn mode and allow the policy to do its work. Okay, let's get started. We're going to start out by logging in as an admin user and switching domains to the appropriate domain. And we're going to use a Windows server where we have already installed the agent and registered it to the DSM. Next, we'll create a key that we'll use to encrypt the data. From the Keys menu, select Agent Keys and click on Add. Give the key a meaningful name. We're going to include LDT in the name because this is going to be a live data transformation key. Select an expiration date and an encryption algorithm. We'll choose AES 256. We're also going to select cached on host so we can continue to have the agent operate and do its job even if the communication with the DSM server goes down. Now we can click OK to save the key. Next, we'll go to Manage Policies from the Policy menu, and we're going to add the Microsoft SQL Server policy, selecting Live Data Transformation, and give it a name that makes sense. We're going to use Learn Mode for this policy. Learn Mode is important when you're developing a policy and applying it for the first time to ensure that you don't disrupt business processes. The pop-up dialog describes how Learn Mode works, which I'll describe along the way. Before we get to that, let's define an encryption key for this policy. We start with the current state of the data, which is in the clear, so we select the clear key. Then we select the transformation key, which is the AES 256 key that we created. Now our policy can take our data from clear to encrypted and back again. Policies are very flexible and allow us to control access based on various dimensions, such as the resource being protected, the user performing the action, or the process being used to perform the action. We're going to create a very simple policy that only has two rules, the first one being created by default for key operations, and the second will be a catch-all deny. We'll start by adding a rule and hitting the Select button next to the Effect field. These are the actions that the agent will take when all the criteria for this rule are met. The catch-all deny should include the deny and audit actions. Keep in mind that the data is already encrypted when this policy is put into place. Learn mode is going to switch the deny to a permit, but because the data is encrypted, we also have to apply a key. If we didn't apply a key, the user would gain access to the data. However, it would be in encrypted form. Notice that all remaining criteria are left blank. This is because a blank acts as a wildcard, matching all. Rules are applied in the order that they appear in the policy, so it's important that the catch-all deny remains the last rule in the list. Also note that once a rule's criteria is met and the effect has been enforced, no further rules will be processed. Any new rules that we create will be inserted before the catch-all deny. Now let's save our policy and move on to applying it to the folder that contains the data files for this database. As I mentioned earlier, we need to choose a method that we'll use to encrypt the data, either by protecting a folder first and copying data into it, or to just apply a guard point and protect the data in place. We're going to choose the latter. So here we're seeing that we have the data stored in a folder on the C drive called bike stores. The difference between the two methods is how long and when the data will be unavailable. The SQL Server database process puts a lock on the database files that we're trying to encrypt. We have to temporarily remove this to apply the guard point. So we're going to stop the service, apply the guard point, and then restart it. This should only result in a couple minutes of downtime. Using the other method, we would create a guard point on an empty folder, then copy or perform a backup to put the data files into it. Data then would only be unavailable while you were switching over the database service to point to the new file location. Let's create a guard point now on the bike stores folder. We go to Hosts, select the host, then click on the Guard Points tab, and click on Guard. From the Policy drop-down list, select the SQL Server policy that we created, and then navigate to the folder on the C drive called Bike Stores. When Windows boots up, Microsoft SQL Server starts very early in the process. To ensure that our data is protected as early as possible after a restart, we're going to check the Secure Start checkbox. Okay, click on OK to save the guard point, and notice that the status is still in red and rekey status is not applicable, so we'll get it started by clicking on Select and then Enable. After that, we should see the status change to green, and we can click on that for more details. The rekey status is still not started, but it will start soon. Okay, we'll switch back over to the SQL Server Configuration Manager and start the SQL Server process. At this point, the database is fully functional. We just need to wait for encryption to complete, but that will be transparent to the user. And if we refresh this, we can see that the rekey status has changed to rekeyed. So the process is complete, the data is encrypted, and the database is fully functional. How long this will take is dependent on how big your database is. If you recall, we created a policy that only had a catch-all deny at the end of it, and we are going to now generate a little bit of traffic so we can understand what the database service is doing when it's accessing data. We'll allow that in our policy, but disallow everything else. A couple of queries should be sufficient to generate the log entries that we need. When those are complete, we can switch back over to the user interface and navigate to the logs. Each log entry contains valuable information. Things like letting us know that the policy is in learn mode and which policy applied, the name of the service that executed the activity, the action performed and the name of the file that it was performed on, and the effect that the policy took. In this case, the write was denied based on rule number 1 failed to match on action, so 1A, and rule number 2 was a match, 2M. So going back to our policy, we would see that 2 was the catch-all deny. Over time, we'd see additional log entries. We'd examine each and draw our conclusions about what we needed to allow and disallow in our policy. Heading back to our policy, we're going to add a rule that allows the SQL Server process to perform actions on the data. So we'll create a process set, and in this process set, we can add one or more processes, and we'll identify those by selecting the Windows Server and going through and browsing for the file. So we'll select the directory that the process resides in and the file name or names that apply. In this case, we're going to use a wildcard to indicate anything in that bin folder will be allowed to perform actions on this data. and we'll select the process set that we just created. Next, we'll select the enforcement. We're going to permit and apply a key in this case to allow access to the data. Save it, then move the rule before the catch-all deny. This rule will match on any action performed by the SQL Server service and permit it, then apply a key so the service has the data unencrypted. At this point, another round of testing would be appropriate, but we're going to move on to activating the policy by taking it out of learn mode. We'll start by modifying the catch-all deny and removing the apply key effect. Then we'll uncheck the learn mode checkbox. Once we save, the policy will automatically be pushed out to the agents for enforcement. Thank you for watching, and I hope you found this video useful.